Hola, soy Ysa.
And I'm Kian.
Today, we're here to learn about deflection of beams and how to solve them. Do you know how to solve them? That's okay because we're here to learn.
That's right. I love solving. This is a great opportunity for us and me to further understand how deflection of beams work.
That's great, Kian. Are you ready to learn with us? Vámonos! Let's go!
But Ysa, where are we going to start?
Good question, Kian. Let us start by introducing our topic. And let's see what backpack has to offer. Can you say backpack? Louder!
Hola, soy Dorothy, the backpack. Ysa would like to introduce the topic of the deflection of beams. I have the stuff for that. In terms of the deflection of beam, deflection is limited to provide integrity and stability of a structure. This also prevents cracks of brittle materials. Because of certain codes we have, members should not deflect too much for safety purposes. Deflection of specific points on beam must be determined if one can see those that are statically indeterminate. Next, we have the elastic curve, which is the curved shape of the longitudinal centroidal surface of a beam due to transverse loads. Then, we have the restrictions for supports or connections. We have the pin or roller support and the fixed support. Another topic that we can discuss is the continuity condition, where the deflection of the left-hand segment must be equal to the right-hand segment, while the slope must also be equal from left-hand to right-hand segment. Now I introduce the topic of deflection of beams. Muy bien!
Wow, I'm starting to understand the deflection of beam, Ysa.
That's nice, Kian. How about you? Do you understand our topic? Muy bien! There's someone behind us?
Ysa, look!
It's right.
He's going to steal our homework.
Oh no! Help us stop him! Say it with us!
Swiper, no swiping! Swiper, no swiping! Swiper, no swiping! Oh, mean, I don't have my homework yet.
Wait, maybe we can help you. We are learning that right now.
Yes, you might learn a thing or two. Really?
Yes! And we can start by solving a word problem step by step.
How are we going to do that?
Let's ask the map to find us a word problem. Say the map.
Hello, I'm Adi, the map, and we are looking for a sample problem. And what better way to use a sample problem for deflection of beam? A bridge! Let us say we are to construct a bridge across the river. The bridge's main support beams are made out of steel and supported by a pin and roller support. The total span of the beam is 15 meters. On the left support, we have the pin. 12 meters from the pin, we have a force of 145 kN. 13 meters from that point, we have a 290 kN acting on that point. Another 13 meters from that point, a moment of 435 kN is located. And lastly, we have a 12-meter distance to the roller support.
Now we solve. We will first create the free body diagram for the reactions AY and EY. On this drawing, we have the forces pressing down on the beam with a total span of 50 meters. At points B, C, we have forces 145 kilonewton and 290 kilonewtons respectively. To get the reactions on the left support, we will now consider AX as 0 and AY, the reaction we will have to solve. We will start from point E, the start of the moment. We'll have the positive 435 from the couple then the force of 290, which is the negative, and times it to the sum lengths of 12 and 13, which is 25 meters. Then another negative force of a 145 kilonewton times 38 meters. And then add AY, and then we're going to transpose, and then we will get the reaction on the left support, which is 246.5 kilonewtons. Next is the reaction on the right support, which is EY, wherein we basically just add all the forces going down and subtract it from AY, which is 246.5 kilonewtons. Then we will get the right support of 188.5 kilonewtons, which is the EY. We then create the free body diagram of the segment DE, wherein there will be a cut and the length will be an equation of x for the force AY, which is 246.5. Next, we have x minus 12 for 145 kilonewtons, x minus 25 for 290 kilonewtons, and lastly, x minus 38 for the 435 kilonewtons. We'll now get the moment of segment DE, wherein the moment DE, we have positive 246.5 kilonewton times x minus 145 times x minus 12, and then we have minus 290 times x minus 25 and plus 435 times x minus 38 equals 0.
After getting the moment, you now need to write the working equation, which is EI in second derivative equals 246.5 parenthesis x minus 145 bracket x minus 12 minus 290 bracket x minus 25 plus 435 bracket x minus 38 raised to the power of 0. In getting the first integral, it's simple as adding 1 in the power of x or bracket and adding 1 in the denominator. You can now just simply divide it in the whole number. In this case, 246.5 divided by 2 is 123.25, and so on. Then, we'll put C1 at the last. In getting the second integral, it's the same process by adding 1 in the power of x and adding another in the denominator, which now becomes 3. Then, we'll put C1x plus C2. Moving on, in getting the boundary conditions at the left support, x will be 0 since there is no distance in the left support, and same as the y, there is no distance upward. Then, you need to substitute all x to 0. C2 will then be equal to 0 since everything will be a negative, like 0 minus 12. It will be cancelled out. Moving on, in getting the boundary condition at the right support, x would be 50 since the length of the beam is equal to 50. We'll substitute x to 50, and solving it we would get the answer of negative 61,709.1. We'll now substitute C1 in the first integral to get the slope and the second integral to get the deflection. It's that easy.